Carefully at the result of applying a translation and a rotation to the same figure. Here we have a weird looking pentagon, and we have a vector fg, which is a translation vector, and the pentagon moves by that translation vector into this second location here. Now that's a translation illustrated by its effect on the pentagon. Let's add a rotation. So I'm going to add a point h, and I'm going to say we're going to rotate the pentagon, not the original pentagon, but the pentagon as already translated. We're going to rotate it around the center H by an angle of 60 degrees. And it's going to move to here. So you can see that it's kind of swept around to this position. It's clearly rotated. Now, the goal here is to understand the net effect of these two transformations placed together. So we have first the translation that moves us from here to here, and then the rotation that moves us from the second location to the third. And I want to say, how do I get from this first location to this third location in one thing? It's a translational rotation. How do we understand that as a single transformation? So you might think that it would be some new kind of transformation that we would have to invent and name, but it turns out it's really just another rotation. The challenge, however, is finding the center of that rotation. And there are two ways of looking at it. One way to look at it is we're going to focus on the pentagon itself as it exists before the action and after the action, and we're going to try to use the initial and final locations of the pentagon to identify the center of that rotation. That will work, but I want to focus our attention instead on the important data of the original transformations. This vector, this point, and the angle 60 degrees. And I kind of want to use the pentagons only for decoration. So let's see how this is going to work. In order to find the center of the rotation, which moves from location 1 to location 3 here, in order to find the center of that thing, the first thing we need to do is we need to translate the segment FG onto the point H so that its midpoint lands on H. That is, we need to construct this segment. Then we need to produce a few perpendicular lines to that segment. And now what's interesting about these perpendicular lines is that points on this left line always move to corresponding points on this right line by means of the vector fg, because these lines are constructed at basically the endpoints of this segment, which is a match for fg. So every point along this line by design moves to a corresponding point along that line by the translation. So, okay, big deal. Now we know that we have a 60-degree rotation around the center H. What I'm going to do is, from the point H, construct a 30-degree angle here and a 30-degree angle here for a total of a 60-degree angle reconstructed at H. So that is, I'm going to construct that 30 degrees and that 30 degrees. Now the reason for these rays is that when these rays are added, because they are 30 degrees separated here and 30 degrees separated here, they're 60 degrees separated from one another. And therefore, this right-hand ray maps entirely onto this left-hand ray by the rotation, which is the 60-degree rotation with the center at H. So then if we identify the points K and L here, which are the intersection points, the points K and L are very special. K, because it's on this left-hand line constructed perpendicular to this segment, it moves to L by the translation given by the vector fg. So K moves to L by the translation. But when L is rotated by means of the rotation of 60 degrees around the center H, it moves back to K because it's swept around this arc, and that's exactly 60 degrees, and it moves back to K. And that means that K is very special. When K is first translated by the translation fg and then rotated by the 60-degree rotation around H, it moves first to L and back to K. It's fixed by that rotation. And that means that if we're looking at the translation, which moves along this vector fg and then rotates around H, K is fixed by that transformation. And that means that K must be the center of the rotation, which maps us from figure 1 here to figure 3. K is the center. Now, what is the angle of the rotation around K that gets us from here to here? Well, there's been 60 degrees of rotation, so it must again be 60 degrees. L is also special. If we had combined these in a different way, if we had first rotated 60 degrees around H and then translated by F and G, then L would be the fixed point of that, because L would move to K by the rotation, and then by the translation, it would move back to L. So if, hypothetically, we had first rotated around H and then translated by the vector FG, then L would be the center of the resulting rotation.